Good afternoon, class. We are looking at Chapter 4, Application of Derivatives, 4.1, Maximum and Minimum Values, Part 2. We've looked at a bunch of examples, and now we are going to look at more examples. Find the absolute max and minimum value of f on the given interval, where f of x is x over x squared plus 2, the interval of 0 to. As I mentioned before, first we have to discuss the type of function. As you can see, this is a polynomial function. So what is a polynomial? This is a rational function. What is a rational function? A function f is a rational function if f of x is n of x over d of x, where d of x can't be 0. Where n of x and d of x are polynomials, the domain of f consists of all real numbers except the zeros of the denominator of f of x, namely d of x. Meaning, when you have a rational expression, in order to get to the domain, you set the denominator equal to 0 and exclude that. So x squared plus 2 equal to 0 has no solutions. The reason it doesn't, because you're adding a number. This is in the worst case scenario is 0. If you pick any number and square it becomes positive except 0, which becomes 0. So it can never be 0. It has no solutions. And it happened to have a rational function where the domain is also all real numbers, just like a polynomials. But normally it's not the case. And because the domain is from negative to positive infinity, so f is a rational function, is continuous on negative to positive infinity, therefore is continuous in the given interval of 0 to 4, which means we are going to find f prime of x. To find f prime of x, we write this as f over g. We use the quotient rule, f prime g minus g prime f over g squared. And so f prime is 1 times x squared plus 2 minus g prime is 2x times the numerator x over the denominator x squared plus 2 quantity squared. And now we are going to work on the numerator to combine them as follows. This is x squared plus 2 minus 2x squared, where we can combine these two into minus x squared. So we get minus x squared plus 2 over x squared plus 2 quantity squared. So we have f prime of x. The next step is to set this equal to 0. When you set it equal to 0, a fraction is 0 when the numerator is 0. So negative x squared plus 2 equal to 0. X squared is 2. X is plus minus square root of 2. The next thing is to look at where the function f prime of x fails to be differentiable, at which point you set the denominator equal to 0. As you recall, we said x squared plus 2 can't be 0, so when you square it can't be 0 either. When you raise it to any power can't be 0, so it doesn't have any solution. So we have only two solutions: positive square root of 2, which is about 1.41 and is in between. But negative square root of 2, which is negative 1.41, is not, so we can only use square root of 2. And we're going to go back to the original function and evaluate it at the endpoints 0, 4, as well as this critical point, square root of 2. So when we plug in 0 into the function, obviously we get 0 over 0 squared plus 2, or 0 over 2, or simply 0. If we plug in square root of 2, when you square it, you get 2 plus 2 is 4, so square root of 2 over 4, precisely. When you plug in 4, this is 16, resulting in 4 over 18, or 2 over 9. If you don't recognize which number is the largest, you have to go with the decimal representation. One easy way, if you multiply 4 times 2, almost you get 9, of course, smaller. So square root of 2, which is 1.41, you multiply by 2 is larger than 2. So clearly this is the larger of the two. So the absolute max is equal to this number at this pair. Absolute mean is equal to 0 at 0, 0. By the way, 2 over 9 is precisely 0.2 bar. So absolute maximum is the square root of 2 over 4, which is about 0.35 roughly. So I like to write the exact answer at square root of 2 comma square root of 2 over 4, and absolute minimum is 0 at 0, 0. In other words, this is the third step. So to recap, to find critical points, we differentiate. We look at f prime equals 0, the numerator is 0. We look at f prime doesn't exist, the denominator equal to 0, which produces no solutions. Two solutions from f prime equal to 0, and we cannot use both because one of them is not in between. So that's something you want to be very careful. Eventually, elementary algebra, go to the original function, and evaluate the original function at the endpoints as well as the critical point. And now the third step, absolute max the largest, absolute mean is the smallest. Find the absolute max and minimum values of f on the given interval, where f of x is x to the power 4 minus 18x squared, and the interval is -4 to 1. Clearly, you're dealing with a polynomial of degree 4, and you know everything there is to know about polynomials. They are continuous from negative to positive infinity, and in this case, not only is it continuous there, it's also continuous in the given interval of -4 to 1. No restrictions. So we need to find f prime of x. That's the first step. F prime of x is 4x cubed minus 36x. Because we want to set it equal to 0, we are going to completely factor it. Obviously, we notice 4x is a common factor, a GCF, and 4x times x squared minus 9. This is in the form of a squared minus b squared, so it becomes x plus 3x minus 3. So if we set f prime equal to 0, we get three answers, 0, -3, and +3. So f prime equals 0 creates three answers. F prime doesn't exist, has no solution. Why not? Because f prime itself is a polynomial. It's a polynomial of degree 3, has no restriction whatsoever. So there are three answers we're going to check. Is 0 in between? Yes. Is -3 in between? Yes. Is +3 in between? No. So you cannot use number 3. So we write -3 and 0 belong. It's an element of the interval of -4 to 1. Therefore, we are going to go to the original function, evaluate it at these two endpoints and these two critical points. The purpose of this question was to show you we may have more than one critical point. In fact, we may have many. We have to check each and every one of them to make sure they fit in the given interval before we use it. And if some of them don't, you cannot use it. So plug in -4. Because the exponent is even, this becomes positive 256. This is positive 16 times -18, negative 288. Their difference is -32. We plug in -3, and again, the exponent in both cases is even. This is even, this is even, and therefore you do get 81 minus 18 times positive 9 results in negative 81. 0 is obviously easy, that gives you 0. And if you plug in 1, you get 1 minus 18, which is negative 17. So those are easy calculations, both of them. All numbers are negative except 0, therefore this becomes the absolute max. We are now looking at this part. So we've already done part 2, this was part 2. And now part 3, absolute max equals 0 at 0, 0. Absolute minimum, this is the smallest number, is negative 81 at this pair, and we write absolute max is 0 at 0, 0. Absolute minimum is negative 81 at negative 3 comma negative 81. Find the absolute max and mean values of f on the given interval. F of t is t times 4 minus t squared to the power 1/2, and the interval of negative 1 to 2. So the question is, what type of a function do we have to begin with? First, when we look at this one, we notice this is the same thing under the square root. So t times the square root of 4 minus t squared, which means the function is a product of t and square root of 4 minus t squared. T is a linear function, and this is square root. So f of t is a product of a linear function t and a square root function square root of 4 minus t squared. So when you want to look at the domain of any function, you look at the restriction. Remember, this is the product of two pieces. The first one is a linear function with no restrictions. So the restriction comes from the second piece, meaning whatever this restriction, whatever it gives us as a restriction, that works for the entire function. So we are going to look at that one. And in this case, 4 minus t squared must be greater than or equal to 0. Why is that? I remind you, in the case of y equals square root of x, when the index is even, then x must be larger than or equal to 0. And if you recall, y equals square root of x looks like that. So the restriction is what's underneath the radical, it must be non-negative. If the index is odd, there is no restriction. So to deal with that, we're going to factor it into 2 minus t times 2 plus t. We set it equal to 0, and there are two answers. T is either -2 or +2. Now we are going to use what is called a sign graph. So what is a sign graph? You draw a number line from negative to positive infinity, and you put these two numbers in order from smallest to largest. So at the bottom, you have negative to positive infinity, and these two numbers, however many numbers, in order from smallest to largest. And there may be more than two, okay? You put the independent variable, it happened to be 2, in many cases maybe x here, and you put the function of interest, in this case was 4 minus t squared at top, and you say, at -2, we showed this one is 0. At +2, this one is 0. So we want to see what happens in between, because we are interested in finding the interval where this quantity is positive or 0, which means non-negative. And so we are going to use test points. Now, test points, obviously, the easiest point between -2 and 2 would be 0. To the left of -2, anything you want, -3, -4, -10,000. To the right of 2 is 3, 4, 10,000. You choose it. Now, when we plug in to the function of interest or infacted form. Sometimes it's easier to plug it in here, sometimes here. I start with 0. When I plug in, I get 4, which is positive. So I would put positive here. Now, I can try the next one, and it makes it negative and negative, or you may recognize this one as each one having an exponent which is odd. These numbers are odd. Therefore, because they are odd, the sign will change. So from positive, we go, it alternates negative here, negative here. However, if any of them is even, then it doesn't alternate. But that would be a fast way to figure out what happens. Always go with the easy case. In this case, is 0 is the easiest one. Positive, and the rest of them is what was mentioned. So what are we looking for? Greater than or equal to. So we are looking at this. Therefore, the domain becomes -2 to 2, and we write f is a product of a linear function and a square root function, is continuous on the interval of -2 to 2. Therefore, is continuous in the given interval, because the interval of -1 to 2 is within this interval. That makes it continuous in that given interval. So the next step is to start with f prime of t. So f prime of t, we use the product rule. F times g, so f prime g plus g prime f. So f is t, we get 1 times the second piece, plus g is half of 4 minus t squared to the power of 1/2 minus 1, or -1/2, times the derivative of the inside minus 2t, and then times the t by the product rule, meaning we have f prime g plus g prime f. Now, this, of course, is the square root. So is this one as a part of the denominator. So this goes to the denominator and becomes a square root. Also, notice 1/2 times -2t squared is simply minus t squared. So what happens is, this is the square root. This one goes down, becomes the same thing. And then 1/2 -2t and t minus t squared. Now, you are going to add these two as a fraction. If you want to add these two as a fraction, you have to make this one a fraction with the same denominator and multiply it by the denominator, square root of 4 minus t squared. That's how it works if you want to come up with the LCD and add up two fractions. So the numerator for this case is simply 4 minus t squared. With this one, another -2 squared, the numerator becomes 4 minus 2t squared. So that's f prime of t. Now, let's look at f prime equal to 0. A fraction is 0 if the numerator is 0. That means 4 is 2t squared. That means t squared is 2, t is plus minus square root. And now 4 does not exist. We set the denominator equal to 0. The denominator is 0 if what's under the radical is 0. We've already done that. And it's plus minus 2 from the previous page. There are 4 critical points. We have to check to see which ones fit in the given interval. And bear in mind, square root of 2 is 1.41 roughly. So is square root of 2 in between? Yes. Negative square root of 2, no. Positive 2, well, it's one of the endpoints. Negative 2, no. Therefore, we can only use those. And we are going to go to the original function in one of the formats and plug in the endpoints negative 1, positive 2, also square root of 2, and evaluate. So as we put in negative 1 into the original function, this negative 1 gets squared up, becomes positive 1. 4 minus that becomes positive 3. And with the negative in front becomes minus square root of 3. Let's plug in square root of 2. When we plug in square root of 2 into the original function, square root of 2 quantity squared, this becomes 2. 4 minus 2 is 2. So this is square root of 2. And believe it or not, so is this one. The answer is 2. If you plug in the last number 2, as you can clearly see, this is, of course, 4. So 4 minus 4 is 0. And 2 times square root of 0 is 0. So the largest number is 2. So we are going for this one. The absolute maximum is equal to 2 at this pair. The absolute minimum is this number at this pair. We write absolute maximum is 2 at square root of 2 comma 2. Absolute minimum is minus square root of 2 at negative 1 comma negative square root of 3. Example 7, find the absolute max and minimum value of f on the given interval, where f of x is x to the power of 2/3 and the interval is negative 2 comma 3. So what type of function do we have? We are going to rewrite this two different ways: cube root of x to the second power or cube root of x squared. Makes no difference. Both of them indicate that you're dealing with a cube root function, which has no restriction. The domain is all real numbers. So f is a cube root function. It's continuous from negative to positive infinity. Therefore, it's continuous in the given interval of negative 2 to 3. Which means we have to follow this and find f prime of x. Again, this is a function which is continuous and it has a closed interval. So we follow the extreme value of closed interval theorem as a result. And to differentiate this, we go with this format and use the power rule: 2/3, x to the power of 2/3 minus 1 over negative 1/3. And that means x to the power minus 1/3 goes down, becomes positive, or 2 over 3 cube root of x. Now we want to find critical points by looking at f prime is 0, f prime doesn't exist. F prime equal to 0 if the numerator is 0. The numerator is a number, there is no solution. F prime does not exist if the denominator is 0. And if you set the denominator equal to 0, x becomes 0. So we have only one critical point. We have to check to see if that's in between, and it is, so 0 can be used. Which means we are going to go to the original function, evaluate the original function at the endpoints negative 2, positive 3, as well as this critical point we just came up with. Now, whether you use this one or this one makes no difference. I'm going to show you both. So if we plug in negative 2 class, means negative 2 to the power of 2/3, which means square the negative 2, you get 4. It's cube root of 4, exact answer, and approximation, 1.5874. As far as you always go with the exact, I'm showing you both, unless they ask you for an approximation. If you plug in 0, obviously it becomes 0. It's very straightforward. But what about number 3? If you plug in 3, you get 3 to the power of 2/3, which means cube root of 9. Again, exact answer approximation. And even if you go with the exact answer, you can clearly see this one is the largest. So absolute maximum equals 3 to the power of 2/3 or cube root of 9 at this pair. And the absolute minimum is cube root of 4 or negative 2 to the power of 2/3 at this pair. And we write it as follows. Absolute max is 3 to the power of 2/3 at 3 comma 3 to the power of 2/3. Again, we're going to go with the exact answer. Whereas absolute mean is at 0, 0. This is the smallest number. I think I mentioned cube root of 4 by mistake. My apologies. So the smallest number is, the smallest value is 0. So absolute minimum is 0 at 0, 0.